A little bit about Baldwin. We are, very briefly, I want to stress, we're a global business. We've got almost equal presence between the Americas, Europe, and Asia. Global revenue approximately 165 billion a year, and this is one of our core technologies. Non-contact spray is one of the technologies we use throughout a number of business areas, including printing and floorboard production, wood production, and today we're going to look at how that in fact is helping our customers in the textile arena. We're a 100-year-old company. We have 750 team members around the globe. The relevance of this is we're bringing new technology to the textile space, but the relevance is that we also have the resources to help support the technology in the space with our customers around the world. I think we all know that there's increasing discussion in the media. We're all increasingly aware of the need for sustainability, and in fact the consumers are increasingly demanding sustainability clarity from the brands, and the customers today are increasingly informed about the environmental impact of the textile industry, including the waste levels, the hazardous chemicals, high energy use. They're also informed about the good things, of course, that textile business does with bringing quality work to different parts of the world, etc. But importantly, I think sustainability discussion is turning more from something that's a newsworthy item once a month, once a year, to the consumers are really demanding action from the brands, and that action is only going to get more as we are, as inhabitants of the earth, more aware of what waste and high energy consumption can bring and the damage it does. If we look specifically at textile finishing, what does that mean? Textile finishing, as most of you know, is the part of the process after the dyeing process that brings a lot of beneficial effects to textiles, such as softness, water repellency, stain repellency, antimicrobial action. These chemicals that's used in finishing, we also have to remember that they require a lot of energy to manufacture the chemicals. So when the chemicals themselves are being wasted, either by over application or excess discharge to drain, we're actually throwing away something that took a lot of energy to manufacture, as well as a lot of money to purchase. Increasingly, it's not a good thing to be putting chemicals into wastewater streams. And in fact, some of the chemicals used here, it's not desirable to even put into a recycling system. The obvious example being antimicrobial, which kind of works against the wastewater system. It's also beneficial to be minimizing the water footprint, minimizing the energy footprint, and very importantly, have a good work environment. And if we come back to the sustainability, traceability discussion, we see every day increasing demand for data to back up the sustainability claims, and it's important to have technology that can generate data that's meaningful and can support sustainability. The traditional method of textile finishing is to use the padding method. So to dip in a bath and squeeze in a pad. Before we start, I think it's reasonable to ask, why is it wasteful? It's well used. It's used everywhere in the world, but we have to recognize why it's wasteful. And the number one reason is quite fundamental. The bath gets contaminated with fabric particles. That can lead to chemicals coagulating. Also, if we look at some of the other useful techniques in the industry, biopolishing, for example, tends to increase the amount of fabric particles coming off the natural fabrics. So there is a lot of fabric particles. So it stands to sense if you're dyeing black, or if you're finishing black fabric followed by white fabric, there's a lot of need to empty the bath and frequent changes of chemical, simply because the fabric and the chemicals are in touch with each other in the bath. And we can easily say that quite often up to 10% of the finishing chemical is simply lost with these bath changes. So once again, we have an energy intensive raw material. It's been wasted and it generates an effluent stream. So there's double problems here. We also in the wet and wet classic finishing process that's used on knitted fabrics. It's very common. It's used elsewhere, but in knitted fabrics, t-shirts, fleece. In principle, it's a very sustainable technique, because you're not drying the fabric before you do the finishing process. However, the chemical bath is continually diluted by water, and you get this tailing effect where the chemical in the bath is continually diluted with the water. So you have to compensate that by overdosing chemicals, and that can lead. One can do simple calculations, and that can require 20% more finishing chemicals than what is required for the functional effect. That leads to waste. So if you take a very simple example, and I try to make this as, I know everyone has a copy of the presentation, so I'll try to hit the highlights. So we look at a medium-sized plant treating 50 tons of fabric per day, applying softener, antimicrobial mix. Industry standard for that is to apply 15% pickup by padding. So there's 7.5 tons of finishing liquor, typically with around 80 grams a litre. It depends on the effect being applied, and quite often there'll be some overdosing to help compensate for the tailing. You can do the math with 7.5 tons, 80 grams a litre. You have 500 kilos of concentrated chemicals going into the mix. If you're overdosing by 20% and losing 10% to the drain, you can be applying 150 kilos more than what is needed to do the job. And that, if you then look at the amount of waste and you extrapolate that over a year, for example, you can be putting 21 tons of chemicals into the wastewater system every year. So there's an environmental impact and there's a financial penalty for that. I hit the highlights here. You can look through some of the detail. So why is non-contact spray more sustainable? And it really addresses the fundamental problem of padding, in that there's zero contamination of the chemicals by the fabric, because there's an air gap between the source of the chemicals, the spray, and the fabric itself. So there is no mechanism for the fabric particles to go back into the liquor, and that really means then, as you do color changes, for example, you don't have to change the bath. because there is no mechanism for contamination. And as I show on the next slide, we also, because we actively control the volume, one doesn't have to worry about tailing. Again, there's no contact between the water bath and the spray application. Therefore, there's no dilution. Therefore, you don't have to overdose. And therefore, one gets a much more constant coverage from the beginning of the batch to the end of the batch. And that also has a quality benefit in that the shade variations that can sometimes come into the padding operation are eliminated also. So again, if you look at the same mass balance that we just looked at for the pad, what we see, and we have done back-to-back tests with our customers, and with the same concentration of chemicals in the liquor, in this application, time after time, we see that you can reduce the pickup from 15% to 12%. So we're now putting on 6 tons of liquor a day, as opposed to 7.5 tons. So there's a lot less liquid involved. There's no significant wasted chemicals. What the fabric needs, the mixed chemistry goes on the fabric. So there's an overall 1.5 ton less liquor consumption a day. That's also 1.5 tons less water to evaporate. So therefore there's an energy benefit. And we eliminate the vast majority of the 21 tons of chemicals, waste chemicals entering the waste stream every year. So the other benefits are with much better working environment. Yeah, the system still needs to be cleaned occasionally, but anyone who's cleaned the fullard and the padding rolls, etc., that's not a nice task. Because of the reduction in pickup, there's increased dryer speeds with the consistent quality as we eliminate the tailing. And increasingly, what we see is our customers report increased softness, because on certain fabrics, especially, are sensitive to the squeezing effect from the second pad. So that translates into improved hand on the fabric. So basically, what I've tried to explain there is that non-contact spray takes us from what is really quite a polluting technology to a more sustainable technology, essentially because it's attacking the root causes of waste, namely chemical waste driven by contamination from the fabric, also the dilution effect that we're getting from the water fullard. So it all comes back. The non-contact is the key part that enables the technology. In the next part, then, I give you a short overview. This is not meant to be a sales presentation in any way, but just to give you an overview of what the technology looks like. We always apply on a vertical fabric lead, and there's no real secret in this, in that when we're spraying inside our chamber, any mist drops, etc., when we have a vertical fabric lead, they don't fall on the fabric, and we've seen time and time again that produces a good effect. So the key parts of our system are, we have a spray chamber, and I'll show you a little bit more about that in a moment. We have a pump station that not only supplies the chemistry, but it also recycles any overspray that we have from the spray chamber. And then we have a very user-friendly user interface where the user can set up the the coating rate or select from a pre-stored recipe, etc. The spray chamber, it's important with spray technology that to have a good environment. So in this case, it is sealed chamber where the fabric runs vertically through the chamber, and we have rubber seals top and bottom of the chamber. The chamber opens for maintenance, it rotates for cleaning, etc. But in the running position, it's a completely sealed chamber. We have the ability to spray either single-sided or dual-side. In a pod, you don't have a choice. You get both sides. But with spray technology, whether it's our spray technology or competitor spray technology, you have the ability to choose to spray either one side or two sides. And in later slides, I'll show you briefly how you can take advantage of this single-sided effect. We, as Baldwin, if we look at the spray technology, it revolves very much around spray nozzles and valves. Part of what we bring to the space is 40 years of refinement. A typical spray machine for textiles has perhaps 60 nozzles. And we all want each nozzle to have a very similar characteristic. And so over 40 years with our partners we have dedicated manufacturing lines for nozzles. We have high precision valves that we use for metering. So instead of having to develop those things entering the space, we bring that technology with us. And therefore, over the last 7 years, have been able to focus on the application with our textile technologist and our global service team. The spray technology that Baldwin brings to the table is somewhat unique in that we have an angle spray pattern, which provides more even coverage and eliminates any tendency that you see nozzle to nozzle variation. With spray technology, many people have reported not being able to get good penetration. We have worked with the technology, we've perfected the technology and validated the technology. And we have many customers today running heavyweight fleets, more than 400 gram, more than in US units, 11, 12 ounce, running that as a tubular fleece. So they were able to get good penetration into the center of the fleece with the spray technology. So spray technology is moving forward, and that is what is making it a very real technology to use in the industry today. We have some other features here that I won't dwell on, because again, I want to keep it more at a high level and not be so much on a technical sell of what Baldwin in particular does. With the pump stations, it's also important that you provide the ability to delicately handle these very delicate finishing fluids. And for example, we use a diaphragm pumping technology, etc. One of the key parts of the journey that we've had is that we've worked very closely with the chemical suppliers, and I have some of the names. For example, some of the Asian suppliers are not on here, and I have to say a big shout out to all the major chemical suppliers, because they've been very positive about embracing the technology, working positively with us and our customers. So all over the world, we're able to, with the help from the chemical industry, bring solutions to the customer that the customer can embrace non-contact spray technology with confidence, not knowing he's not taking a risk because he has partners, not just from the spray supply company, but from the chemical companies. And that's an increasing part of the journey with spray technology. The chemical companies are very much embracing that technology. Spray technology is very easy to retrofit into systems. It's quite compact. These are some open width examples, but it's finding some horizontal space where you can install some vertical beams, and as you can see in the photographs, it's really quite straightforward to install the technology, and it requires some passageways either side so that you can service the technology, but overall it's really quite compact, and we've been able to retrofit quite easily into lines around the world. If you look at what you can do with spray technology then in terms of technical fabrics, and again I'm back now to generic presentation. If we look at a technical fabric where you want a stain repellency on one side and you want a flame retardancy on the other side, one of the classic ways to do that will be to first of all apply in a pad, apply the DWR and simply dry the fabric as a single pass, and then either in a second stenter or you return back to the beginning of the first stenter. The fabric now goes through again and we'll get a latex back coating, and this time we will polymerize in the center. So it's a two-step process. With spray technology, here this is the advantage of single side. We have the ability to spray on one side of the fabric, so spray the top side of the fabric with typically in this case 15 to 20% pickup. So again, the ability to apply just the amount of liquid needed to do the job, and then simultaneously in the same pass apply the back coating and then go directly into the stenter. So utilizing spray technology in this way improves stenter utilization. Overall, we typically are able to run faster because again there's less water and less pickup involved on the side. There's a dramatic reduction in water used in the DWR stain repellent process, and as in the previous examples, you eliminate the padding waste because there's no bath to empty when the job is done. Quickly then, another example then will be is if you want to take a laminated fabric and apply DWR to the fabric. Again, it's a multi-stage process where first of all the DWR will be applied in a pad, followed by drying. Then we have the lamination process, and then we go through again to polymerize, all the while having some risk of in the lamination process. So there's very careful process control required to make sure the DWR does not affect the lamination. With spray, the product can first be laminated, and after lamination we can spray the DWR on the face side of the fabric where it's needed. There's improved performance in the lamination, and the DWR chemical is put on the single side where it's wanted, and so there's reduced chemical use, but most importantly less process steps, less stenter utilization, less energy used overall, and once again as always, we eliminate the pad waste. We can read the detail, but we also have, you know, this is very much a real product that is running in sites globally. So some testimonials from some customers. Feel free to read them after the event. We support the industry very much with lab testing, both in Sweden and in Japan. So if you have some samples or some fabric and you want to verify that it will work with spray technology, we have the ability on to spray A3 size samples. We can, if it's a water repellent type test, we can do the type 22 test in the house, water alcohol repellency, and importantly, we also have the ability to evaluate the shear stability of the chemical and verify that there is no problem with the chemical being stable through the spray process. So we have that facilities here in Europe and in Japan. In North America, we're very pleased to have a partnership with one of the best known global universities in the textile space, North Carolina State University. And in their fantastic lab, we have a TexCoat installed in front of one of their stentors, and they're with the ability to run pre-production tests for customers on knits, wovens, non-wovens up to 3 meters wide. And so it gives the customer the opportunity to do an industrial scale trial. In our own facility in Lauterbach in Germany, 1 hour north of Frankfurt, we also have a TexCoat installed in our roll-to-roll test line. There, interestingly, we can evaluate the benefits of plasma treatment. We can spray with TexCoat and dry. So again, in Europe, we offer our customers the opportunity to run pre-production scale testing. I'd like to thank you all for taking the time to listen this evening. For our colleagues in Europe or in the Indian subcontinent, Southern Europe, next month, initially in Pakistan, we will be exhibiting together with our partner in Pakistan at the IGATEX exhibition. We're in Hall 2. And in India, then in the second week of December, we are in Hall 7A. And we're looking forward to be back at ITMA next year and Hall 14 in Milan. So I thank everyone for their time.